Hello, welcome back. Today in this video, let us understand what is Cosmos DB throughput, and there are different types of throughput. I mean, defining the throughput at a what we call as shared throughput and dedicated throughput in Cosmos. So let us understand this. Also, if you are new to this channel and haven't yet subscribed for this channel, please do like and subscribe, and also don't forget to press bell button for instant notification. So also just check the previous content of this playlist, so where you will understand what is the Cosmos DB introduction, and it's what are the features of Cosmos DB, and there are different APIs of Cosmos DB. So we have seen in the previous video. So if you have not seen that, I recommend you to watch the previous videos of Cosmos DB playlist. And we have also seen Cosmos DB account creation, and also we have learnt about Cosmos DB partitioning. So in this video, let us know the throughput and different shared and dedicated throughput, right? So let's get started. So before jumping into different types of defining the throughput, so let us understand what is throughput in the Cosmos DB, right? So you might have already heard about throughput if you are familiar with kind of a RDBMS or relational database, right? So or else if you're familiar with the networking concept also. Throughput is simply the amount of data that is moved successfully from one place to another place in each time. So this is a simple definition, generic definition of throughput. That means this is a networking definition basically. So if we need to understand this definition, this will hold good for this Cosmos DB throughput as well. That means what is the volume of data, the amount of data, whether it is one document, two document, 10 document, what is how many KBs, 10 KB, 20 KB, 30 KB. So that is a volume, right? Amount of data. So that will be moved from one place to another place, right? In each given time. So here they are mentioning one place to another place, but in Cosmos DB it means the operation, the successful completion of the operation. That means the input and output. So whatever the input we are giving, the input might be any operation for that matter. You want to read the data, you want to insert the data. So that will be the one place. I mean, that is the insertion. That is like input and output. So when you say another end, that means you will get the result back, or you will get the record inserted. So that is what the Cosmos DB throughput that we are defining. Right? And when we are talking about throughput, the RUs also come into picture, because RUs means request unit. So request unit is nothing but it is how many reads, how many writes, how many stored procedures, or maybe having a TTLs like time to live settings. So each one of these will be having, will consume the RUs. Okay, what is RU? RUs means request unit. It is nothing but there is a throughput. So this throughput, what we discussed, right? It is measured using request units. So request unit is a combination of CPU, memory, and IOPS. Okay, so whenever you are saying I want 400 RUs for a particular container for a particular Cosmos DB, that means you are basically asking the capability of CPU, memory, and IOPS combined. Okay, that we call it as a 400 RUs. So this will be running in the background. So CPU, memory, and IOPS, we will not, as a user or end user, will not see this. So this will be provisioned by Azure in the backend. And when you say, and these RUs are also useful for when you're considering the cost, right? So Azure Cosmos, basically Microsoft Azure will charge you based on these RUs. How many RUs you are consuming, so that many number of dollars or rupees or whatever currency. So based on that you will be billed, right? So here minimum is 400 RUs and is extendable manually or auto scaled. That means a minimum we have to use for 400 RUs. Suppose if you are creating a container or database level request units, so then you have to define at least 400. Minimum is 400, and you can also enable the option of manual and auto scale, that we will see in the detail in some time now. And beyond that, so if you are consuming beyond this, suppose if you are defining 400 RUs but you are using more than that because you are performing a lot of reads, writes, or some stored procedures are running, right? So at the same time, in that case, what happens is you will be rate limited, and you will definitely get an error from the Cosmos DB regarding that. Okay, so moving to the next slide. So this is important where we understand the difference between shared throughput and dedicated throughput. So we can define the throughput as a shared and dedicated. So what does it mean? So you have a Cosmos DB, as you know, inside a Cosmos DB you can create multiple containers, a number of containers. Okay, now if I'm just seeing the option 1, which is a database level. When I say database level, you may have 3 containers here, and I'm defining something like 1,000 RUs. Suppose I'm defining a database level 1000 RUs, request units, right? So in this case, what happens is, so container 1 might get around 200, okay, and container 2 might also get 200, so that's become 400, right? So rest 600 might be given to the container 3. So here it is 200, 200 and 600, total become 1000. So how it is deciding? So how container 1 is getting 200, container 2 is getting 200, but container 3 is getting 600. So this will be decided by the Cosmos DB itself. So we cannot intervene here. So that depends on the multiple factors here, and that depends on the workload of a on a data workload, or that might also depend on the data volume or the partition key that you are using, and basically it's the total workload that at a given point of time. So that will actually decide this deciding factor of what container will use how much of the RUs that are defined at the database level. So here it is a simple calculation, right? If you are giving 1000 in total, Cosmos container, whatever how many containers are there, that will share among this total database level RUs. Okay, it can be 200, 200, 600, or it can be 400, 400, 200. So end of the day, the total will be database level, whatever you're giving. So this is option 1 that you can define. So coming to the option 2, which is at a container level. So whenever you're giving at a container level, what happens? So if you're giving a here, so I'll be mentioning instead of database level, I'll be mentioning at a container level. Each container, how much RU it should have. Suppose I'm defining the container 1 should have 500 RUs, container 2 should have 200 RUs, container 3 might have 1000 RUs. So here I can define RUs for each container, right? So what is the advantage of doing it, right? So suppose container 3 might be of a very critical operation. It might be doing some business critical operation, right? In that case, if you are giving 1000 RUs, this is dedicated to only this container. Even though it is not using this 1000 RUs, so it will not be shared to the other containers. So that is the whole concept of giving a dedicated container here. So this might look little costlier, but so this is a recommended or best option when when there is a business critical process or applications running on top of this container. So I hope this is clear. Whenever you want to go to the shared throughput, right? So you have to define it at database level. If you want to go at go regarding the dedicated throughput, so then you have to go for a container level. So this is important to understand. So hope this is clear theoretically. And let's go for the next slide, where we will see a summary and quick demo. So whenever you are seeing like a business critical operations, right? You have a business critical operations or applications. So definitely you need to go with the container level. That means a dedicated throughput. So in that case, definitely the dedicated throughput is the best choice. And so you don't have say like not a business critical application, or so not performance intensive operations that you are performing. In that case, definitely you can save the cost by using a shared throughput, because whenever you go for a this dedicated throughput, right, what happens whether you use that RUs or the throughput or not, so you will have to still reserve that amount of RUs for that particular container, and you will get charged whether you are using that or not. So that is that is a trade-off. That is a analysis based on your use case that you need to perform here, what you want, like based on the business critical operations or the cost that you want to decision that you want to make here, right? And definitely the recommendation is always to have a dedicated throughput, because it will always give the optimal performance, and also here you might need a kind of analysis to particularly come to the conclusion how many throughput each container want. Suppose a container 1 is there, so how many throughput it might need. So like if I'm saying 1000 throughput, so that comes based on some analysis. You need to perform some POC, or you need to perform some data load. Then you will understand is the 1000 is sufficient. If it is actually sufficient or more than enough, so you need to monitor the utilization. If it is say beyond 20% or 30%, so then you can bring this dedicated throughput to 500. Okay, so that's how you need to come to the conclusion whenever you're giving a dedicated throughput here. Okay, so then let us see the last piece here. I was talking about a database, database and container so far, right? Because I'm considering the SQL API. But if you're say you are using a MongoDB API, so in that case you'll be having database, but you will be having collections instead of container. You'll be having collections there. Similarly for Cassandra, Gremlin, and table storage. So these are the these are the options basically for shared and dedicated. I'll not go in detail, but so this is how it is. Shared versus dedicated. So we have seen in this video one example like database versus container, database level and container level. So that will holds good for other APIs as well, as you're seeing here. So coming to the demo part, so I am into Azure portal and inside Cosmos DB, so which I've already created. And inside Cosmos DB, when I click on new container, you can see here it will open up this blade where you can give the two options, that is create new database or use existing database, where you want to create this container. Basically it is asking. So I say I want to create a new database here, and as you can see there is an option. This is what we are discussing, right? Whether you want to go for a shared throughput or dedicated throughput. So if you are not clicking on this, then it will be dedicated throughput. If you click on this, then it is a shared throughput. So shared throughput, as we discussed, is nothing but you are actually sharing the throughput across the all the containers that is being created in this database. Simple as that. Okay. Or else if you are unchecking this, you can see here that options will be gone. So that's the difference. And whether you use a shared throughput or dedicated throughput, you will have one thing common. So that means you have to define the what are the number of RUs. So RUs is nothing but, if you can see here, so RUs are the highest. That means what is the maximum RUs that this container can use. So the minimum is 400. That we need to define at least 400 RUs, right? So and you can read here what exactly it is giving the message, right? So this message is based on the what exactly you are selecting. So whether you are selecting a shared throughput or dedicated throughput, here one more option will be there, that is auto scale or manual. So when you are giving the auto scale here, what happens is you are 10%. That means 10% of 4,000. That is 400 RUs. From 400 RUs, it will scale up to 4,000 RUs. So if you are giving, if you just go on adding the zeros here, so as you can see, it changes 10% RUs from 10% to 100% RUs. So whatever you are giving here, so it will be auto scale. And if you are giving manual here, so it is just you are just fixing to the number of RUs that you want. So in this case, there is a problem. I mean, if you are choosing a high number of RUs, right? What might happen is you might not be using those number of RUs then, but still you will be charged for this number of RUs. So that is the harm when you're giving the more RUs with respect to the manual setting. Okay, but in auto scale there is a possibility of saving the cost because it will be scaling up and scaling down automatically. So yeah, that is the, I mean, if you're having a business critical application, yeah, definitely then go for a manual and then give whatever you want, right? Like how much RUs based on your calculation, you can go for that. So coming back to the slide, right, so that we are discussing here, as you can see, I'll go back here. So we have seen in the demo, that is database level and container level, also these two operations, we were just seeing this. As you can see here, when you're clicking on shared, then that means it is a database level. When you're unchecking it, it is a container level. This is a container level, option 1 and option 2. So both we have seen in the demo. So how we can use that, right? So that is about it, and thanks for watching.